Hello, this is question 7 on your June 2019 paper 1 from AQA. And you have to sketch the graph of y equals 1 over x and y equals sec 2x in the same axis. 1 over x is a reciprocal graph and this is just a trigonometric graph. And we have to show that this equation has one solution when x is greater than 0. So if we represent the reciprocal graph, is going to look something like this. So we have an asymptote here and an asymptote here, and we have another branch, but they say when x is greater than 0, so we can ignore this bit. And the y equals sec 2x, remember that the graph of sec x is something like this. Is doing something like this. So yeah, I would really recommend you to remember the shape, even if you don't remember the values, because the values can be found with the calculator, but if you remember the shape, it will be very helpful. So this value here, and remember sec s, so sec s is the reciprocal of cos. So the asymptotas are going to be when cos x is 0, because when cos x is 0, this is undefined, and that's where we have the asymptota. Cos x is 0 when x is pi halves, but we are not representing sec x by sec of 2x, which means is a horizontal stretch with scale factor 1/2. So my asymptota, instead of being in the pi halves, is going to be in the pi quarters. Yeah, so every pi half, so I'm going to have an asymptote here in the pi quarters. So this is pi halves, pi quarter. I'm going to have an asymptote here. I will have the symmetrical, and then every pi halves I will have another asymptote. So my first asymptote is going to be somewhere here. So that's the vertical asymptote in the pi quarters. So my sec of 2x graph is doing something like that. Well, it's not touching, so it will be doing something like this. And this is 1. Yeah, remember the asymptote, this value here is 1, this value here is -1. This would be the solution that we are looking for. The next asymptote could be in 3 pi quarters. So I'm adding pi halves. So 3 pi quarters is still here. So this is the next asymptote, and then my graph will be below, doing something like this. This would be the -1. The next one would be here. So every pi half, and this asymptote would be here. So this is, we say this is 3 pi quarters, and this is 5 pi quarters, and so on. Yeah, so my graph could be doing something like that. That's how I can see that the 1 over x and sec 2x have only one solution. Yeah, this one. And the next part, they say, by considering a suitable change of sign, show that the solution to the equation lies between 0.4 and 0.6. So this is the equation, and we can write a function that is the difference between both of them. So 1 over x minus sec 2x. And the solution to this equation is a root of this function. So this equation is the same that having this equal to 0. And I'm going to have a solution between 0.4 and 0.6 is if this function has one sign for 0.4 and a different sign for 0.6. So what I'm going to do is f of 0.4 and f of 0.6, and if they have different signs, that means that there is a 0 in between them. You just do with a calculator in radians, because the graph is drawn in radians, so we are going to use radians for this. Sec is not in the calculator, so what you are going to do is the reciprocal of cos. Yeah, in this case cos 2x. So we can write this as 1 over x, so 1 over x minus 1 divided by cos 2x. When we do that, the first value is 1.064 something, and the second value minus 1.093. So one is positive, the other is negative, therefore there is a solution in between them, no? So there is a solution between 0.4 and 0.6. Yeah. Next part, it says show that the equation can be rearranged to give this other equation here. And the equation, remember, it was 1 over x equals sec 2x. No, it's this one. So the equation is here, this one. So if we write the sec as the reciprocal of cos, we can write this. Just writing sec as the reciprocal. This fraction and this fraction must be equal, which means if the numerators are equal, the denominators must be equal. So I have that x is going to be equal to cos 2x. And this is now like having something like, I don't know, 0.5 equal cos 2x. What I do to find 2x is cos minus 1 of 0.5. So I'm doing the same. 2x is going to be cos minus 1 of x. And I just make x the subject. So x is going to be 1/2 cos minus 1 x, which is, what I have to prove. Yeah. And now the next part, we have to use the iterative formula xn plus 1 equals 1/2 cos minus 1 xn with x1 equals 0.4 to find x2, x3, and x4 to 4 decimal places. So what we have to do is x1 is 0.4. We are going to substitute to find x2, x1 by 0.4 here in the calculator. So if you do that, x2 with the calculator is 0.57963 something else, and we round to 4 decimal places. And this is what we have. To find x3, what I'm going to do is to substitute this value in the calculator here. But instead of the rounded one, please be sure that you use the not rounded one. So you keep that value in the calculator. You know that you have a key that is ands, usually is by the equal. And if you click on ands, so you do 1/2 cos minus 1 ands, is using the previous answer. So that's a way. And if not, you can just save it in the memory. But please use the non-rounded values and then you round after. So these are already rounded. And we keep doing until x4. Yeah, we substitute each value. And these are the values. And the last thing they ask is on the graph below, draw a cobweb diagram to show how convergence take place, indicating positions of x2, x3, and x4. So this is the graph, yeah, our function, and this is y equals x. This is the one that always we use. We start with x1 that was 0.4. So we start here in the 0.4. This is my x1. I have to go up to the graph, or we can even do a straight line. So, to my graph. So this is the first point. I go to the straight line, the y equals x, and this is my x2. So, and I'm going to, so this is going to be x2. x2, it seems that is 0.57 something, yeah, which is precisely what we have. Then I go left until I meet the other line. Stop here. This is my next value in the iteration. This is my x3. That seems that it is 0.47. Yeah, perfect. And then I go up one more. And my next value is this one here on the right. So I just go like going in circles. So this is my x4, which looks like 0.54 something. Yeah, 0.53. Yeah. And that's how you check if this is getting closer and closer. So if you carry on finding x5, x6, they will be closer and closer and closer to the solution of the equation. Yeah, and that's all with this exam question.